All right, so this is the first handout here. So these are these distance equals rate times time problems. So distance equals rate times time, pretty much. All of them are. So, and what I mean by that, if you look at this, is like y equals mx. And sometimes there's a plus b on this. It just depends if there was a starting position or not. We'll kind of explain that as I look at this first problem, or I will. So here we go, Fabio going from Albany towards Buffalo. So this is, we're going to put the work right over here. Here's Albany, mark it with an X there, uh, towards Buffalo. So Buffalo's over here, and there's your car, and he's driving along. Oh, why my cars always look like they're all going backwards. There we go. Now this guy's going Albany in this direction. Okay. Um, And it says what interstate they're going on. That doesn't really matter. At a constant rate of speed of 62 miles per hour. So there's our rate. So that's like your slope. Um, but more importantly, I guess, is to think of this 62 as a ratio, miles per every single hour. And so it works just like a rate. Distance equals rate times time. There's your rate. And if you take it times time, if your time is like 1 hour, take this times this 62 miles per hour and you get 62 miles. So it gives you the distance you've gone. If t is 2 hours, when you multiply, it tells you you've gone 124 miles. So this distance equals rate times time. That's kind of part of our problem here, even though they didn't even talk about it. Um, anyway, so as they're driving along here, we can predict how far they've gone. We know they're going 62 miles per hour. So miles per 1 hour. And if we take it times t, however long they've been going for, that would give us the distance they've traveled. And now they've given us some information here. They told us after 1.5 hours, so t equals 1.5 hours, the distance they've gone from Albany is 221 miles. Right. So these are just like ordered pairs now. At t equals 1.5, d equals 221. Now, what they want you to do here is write an equation that tells you how far away from Albany as a function of hours uh, that Fabio is while he's driving. So as he makes this trip, I'm going from Albany to Buffalo, we want the equation that calculates how far away he is from Albany. So let's start writing it. There's the form they want you to use. Now, instead of using y minus y1 equals m times x minus x1, that's our point slope form for an equation. Have to have that memorized. Um, Instead of saying, hey, write the equation in point slope form, they said use this model with d's, and d sub 1 equals m times h time minus h sub 1. So what are they doing here? Well, they're saying use distances for your y values and use for your x values your hours. And so we can do that now. This is our hours. This is like h1, and this is big D1. And so here's our equation, d, which is going to be in our answer, minus d1, which is 221, equals m, our slope. But we know our slope is that 62 miles per hour, times x minus x1, which is 1.5. And there we are. That's our answer in point slope form. Okay. Now, in part B, if you look what they ask you to do, it says rewrite this model. So this model right here. By the way, this should not be an X. That should be an H right there. Just notice that. This would be just H right there. So it fits the model that they wanted us to have. It's really just this equation. All right. Now we got to put this thing in slope intercept form. So in slope intercept form, we usually want y equals mx plus b. So for this one, d equals mh plus b plus b. That didn't look very b right up there. Okay, so let's go ahead and rearrange this answer we just got and put it in the slope intercept form. So I'm going to rewrite this equation right there. Now, as I rewrite it, I'm going to just copy the D there and the minus sign and the 221 equals, and I'm going to go ahead and distribute that 62. And I'm going to have to take 1.5 times 62. Let's see here. That'd be 62 plus 31. So it'd be 93, I think. And then we're almost into slope intercept form. We just got to get rid of this one or 221 here. So we'll just add 221 to both sides. Line him up with his like term over there. And so D equals 62H. And plus, let's see here. If I took away 100, that'd be 121. So I think this comes out to 128, something like that. And that would be your answer then in your slope intercept form. Ooh, it wants it written as a function. So we go D of H. Write it in the color you can see. D of H equals 62H plus 128, just like that. Um, so this is just asking you to find in part C here, how far was he from Albany when he started the trip? So in our little model here, from Albany going to Buffalo, and our car is driving in that direction to the left. Okay. He didn't start apparently at Albany. He had a head start when we wrote our equation. How do I know we have a head start? Because the equation that we came up with here is not really distance equals rate times time. It had this extra little b value on it, this 128. And distance equal rate times time doesn't have that. So why did it have the 128 on it? That's because he started 128 miles down the road already. And so as he does his distance equals rate times time, we just got to add the original distance he had already traveled plus the extra rate times time part that the equation calculates. Now that's what's going on mathematically. What they want you to find is what's the D of zero. When hours are zero, I haven't started my trip yet. Where was I located? 62 times h is 0 plus 128, and you can see you get 128 miles that way as well. And finally, D here. Total distance from Albany to Buffalo is 290 miles. How long does it take him to reach Buffalo? Well, in this case, they're saying, hey, the D of what H value gives you 290, the total distance. And so this is that function notation that you had in the earlier stuff we were talking about. This is an output value here. And so we take the equation for the function and we say, hey, when do you equal 290? Because that would be the whole distance. And just solve that guy and figure out your H. So subtract your 128. I'll let you finish out that math. Let's see here. 5. Ooh, we got ourselves a rocket taking off from Earth's surface. It's using up fuel. And when you see this uses up fuel, that's a subtraction problem. It is losing 12.5 gallons every single minute. Okay, so this is a counter right here. It takes away, if I take this times time measured in minutes, like if 1 minute goes by, when I multiply, I lose 12.5. If 2 minutes go by, T is 2, this would lose 25 gallons, two of these 12.5s. So when you see a slope, it's a counter for something being gained or lost. In this case, you're losing gallons for each minute. So take it times time, the number of minutes, and it tells you how many gallons are lost. And that's the exact equation I'm almost certain they want you to find here. You start with 225 gallons and you're going to be losing 12.5 gallons per minute. So your function immediately looks something like this. I'm losing this much, and as T gets bigger, I lose more and more fuel. Okay. Write the linear model, F of T. So fuel as a function, fuel here as a function of time would be, hey, I started with 225 and I lose 12.5 times t. If t is 1 minute, plug in a 1, I'd have 225 minus 12.5. If t is 2 minutes go by, it'd be 225 minus 212.5s or 25. So this is calculating my fuel. Below is a general sketch of what the graph of your model should look like. Use your calculator, determine the x and y intercepts. Um, you can use your calculator for that if you want to. But if you want x and y intercepts, x-intercept, it's down here. So that's the point where your y value is 0. So you just take the equation, find out what it equals 0. And that's not too bad of a solve because it's just, a couple of steps here. That'd be a negative 225. So you're going to have to divide away that 12, negative 12.5. But that would tell you that value. And then similarly, this other one, you don't need a calculator for your y-intercept. You can calculate him. That's just, hey, when x is 0, figure out the y value. That means just find the f of 0. Put an input value of 0 right in here. And you can see that just gives you 225. And so that one's 225. So you don't really need a calculator to find the x and y intercepts. And the rocket must still contain 50 gallons of fuel when it hits the stratosphere. What is the maximum number of miles the rocket can take to hit the stratosphere? Well, here's our equation that calculates how much fuel we have based on time. We got to have at least 50 gallons or 50 gallons exactly. So just set it up like this and find out. Oops, that's 12.5 T. What makes it equal 50? That's just a two-step solve again, right? Subtract your 225, divide away 12.5 or negative 12.5, you'll get your T. All right, so I think you can finish that guy. Let's check this answers out. So I'll just kind of run through them and check. Which of the following would model the distance D a driver from Chicago if they left say 50 miles per hour and started 256 away? So that'd be, hey, I started 256 away and I'm adding on 58 per T. Alrighty, so you chose this one with the minus sign in there. Um, you might be right because I could have read it wrong. Which of the following would your model the distance a driver is from Chicago if they're heading towards the city and started 256 away? Nope, you were right. My bad. Yeah, so that should be 256, and the distance from Chicago, because they're driving towards it, they take away that time, that distance, because it'd be getting smaller and smaller and smaller. That looks good. Bikes is 2 times 2 equals R minus C, so P equals your R 350X minus C. Be careful here, you got to subtract the entire C, which means you're going to have to distribute that negative, which would be 350x minus 22x minus 132. So this part you got correct. It looks like that's the 328x, but you've got to distribute that negative sign. So you want the minus 32 on that thing. Okay. The way you can figure this out is when you look at this notation, R subtract C. So this now says subtract, and by using parentheses, you're subtracting all of C versus what you wrote, subtract the 22x, but not subtract the 132. But that's part of your C, so it needs to be subtracted as well. Okay. Um, and that really corrects if as long as you follow that rule, this rule kind of when you do something like P equals R minus C, you can always slap these things in parentheses. So your R would go first, 350x, and then you put parentheses minus, and you put your C in parentheses as well. And then, if you do have to distribute anything, it shows up if you always use parentheses. Okay. So I would do that. Number 3 here, average temperature given by this equation is that, and X is number of years since 2000. So 2100, yep, that looks right. Plus 4, yep, 18.71. That one checks out. We'll take 20 degrees, subtracted 14 from both sides, 0.004. I'm going to take your word for this one. There should be an X right there, but it looks like you divided by that. Yeah, so division by 0.04. Yeah, divide by 0.04. Uh, is that an X next to that thing? Let's see here. I'm going to pull out my calculator real quick. It won't show up on your screen. I'm just going to check your number there. So 579. Oops, here, 5.79 divided by 0.04. Yeah, check that. So right here, it looks like 5.79. 20 minus 1. Oh, that's a 5.29. That might make the difference. 132. Yep, you are correct. That works out. The notation here, though, is a little bit not so clean. And it's this X that's really throwing me off a little bit. So this should be like this with an X right next to it. And then the next thing you should show is that, hey, I'm going to divide by 0.04, 0.04, and then X equals that 132.25. No X's by it. And you want to slap some units on this thing. Uh, years. And that you might even go years since 2000, I think this is. Sketch a graph of this thing. So you're just trying to sketch this equation right here. Okay. We had one just similar to this on the previous page where they do just this line graph, something like that. And you just have to find your highest end and your lowest points. But this one, if we look at its equation, it is y equals, or c of x equals 0.04x. I've rearranged it here just a little bit, 14.71. So your highest value or your y-intercept, that's just your 14.71. Your x-intercept, you're going to have to calculate that. Just when does this thing equal 0? To find out when it equals 0. Although you really don't even have to do that, I guess, because now that I think about it, we only know this from 2000 and on. So this is like the year 2000 with an x value of 0. And I got my graph going the wrong way because this graph is an increasing graph. So we better start down here. There's its y-intercept, but we're going uphill. And they want us to do it over the interval from 0 to 200. So you're going to have to figure out when x is 200, what is this y value? Okay, so your graph will look something like this line, start right here with that y-intercept and increasing till you get to this maximum. And that's maximum they want you to look at is right here at 200 years. Okay, so just calculate the C of 200. Okay, so just like you found the C of 100, do the C of 200. It'll give you some temperature. That's your high point. Okay, so you won't have all these dotted lines when you get done. But once you know this number here, just by doing this, you'll be in good shape. All righty, I think that'll get you through it. This took a little too much explaining maybe. Oh, what does this model project to be the average global temperature in 2200? So in 2200, that's this value that you're finding right there. Okay, because that would be 200 years after 2000.